Hi everyone and welcome back to my desk. Today I have a new tool, so we will go over this multimeter that was kindly sent by VENLAB to me. This is not a sponsored video. They did send the multimeter for free, but this will be an honest review, and everything that I'll say in this video is my own personal opinion. The idea is that we'll take a look at what's inside the box, and then we will compare it with my multimeter that you've seen me using many times on the channel. Hopefully this will be an addition to this for situations where I need to measure two voltages or when I need to make measurements of current and voltage at the same time. So the multimeter that VENLAB sent to me is very much welcomed in the workshop. I'll start by first opening the box. This is how it came from the shipping box, so I haven't opened this. And inside we do have the multimeter, we do have the test leads and the user manual. So on first glance it looks okay. It's a relatively small meter if I compare it to my normal meter, and if you are someone that works remotely, that might be a good thing. On the bench, I don't think it will make a difference, and the leads definitely feel quite nice. I'm not sure if there's a... yeah, we have these covers that add like an additional layer of insulation, which is good if you are poking around with the meter. So definitely I feel as if this meter is primarily intended for use within people that are remote and work on some job sites. Tried to turn it on, but obviously there are no batteries inside. And what's specific and interesting about this one is that it uses two AA batteries instead of the 9 volts that I have on the other meter. So let's add some batteries and see how it works. Okay, so right off the bat, what I can immediately notice is the difference in the style of the displays. On this one, you can see that there is a bit of space around, and on this one, the screen is taking the entire real estate. So when I'm looking at it from the side, I'm kind of losing the bottom of the numbers. There is a stand on the back that I can raise it, and it's now perfectly visible. So probably this is the way that this meter is intended to be used. And the first measurement that I will make is the resistance in continuity mode of the leads themselves. Let's see. Okay, they go to 0, and compare that with my old meter, and I was used to seeing some resistance on the meter. So you see 0.5 ohms is what I had on the leads, and this one is measuring as nothing. So direct short, or yeah, 0.0. So that's the first difference. I don't know if that is difference from the meter itself or from the cables, but we can see how it behaves on different measurement. On this one, the diode measuring is on the same position, while on this one I have it here on the 2K. Here I have 1N4007 diode. That's a typical diode that's used in many applications. This way it reads OL. If I flip it, then we read the 0.542 voltage drop. Let's see the other one. So this way it reads nothing as open circuit, and this way it's 0.621. So that's quite a difference between the meters. Let's see what it was here. I think 0.5440. Yes, so there is quite a difference between the two. That's on the diode. For the next test, I will only do it in the VENLAB, the VM-200M, because it has a dedicated transistor tester, which I don't have on this model. So let's see how it reacts. This is the standard 2N222. So let's see. And it reads 276, and I believe that's the voltage drop between the legs, and we have the same for the NPN. So that's one thing that I'll now have the ability to measure. I still don't know what that is. Probably it's the current or voltage difference that triggers the transistor to be conductive. I'll look it up. Okay, so now for the next test, I have an assortment of resistors that I'll measure with both of the meters. So I have 1 ohm, 10 ohms, 1 kilo ohm, 10 kilo ohm, 100 kilo ohms, 1 mega ohm, and 10 mega ohms. So maybe I should add 100 ohms. Okay, I also have 100 ohm. So we have resistors from the entire range, and we'll see what values we get from the 2 meters. I'll start from the lowest measure. So 1 ohm. I'll hold the resistor by one leg and I'll touch it with the other one. So this one reads 1.1. Let's see the power fix. And this one reads 1.7. But keep in mind that I had 0.7 or 6 on the leads. So basically they are reading the same value, while this one is immediately telling that value correctly, which I do like. And also, if you heard the beep, the power fix has the beep and the low ohmage measurement on the same pin, which when measuring resistors this low brings me nuts. So let's measure. This one is 10 ohms. I'll measure it with the power fix. So 10 ohms plus the resistance of the leads. Let's see what the VENLAB will say. 10.3. Okay, so there's slight discrepancy there. I'll move to the 100 ohm. 98.9, and this one will be 99.7. So I'll have this all measures in a table, and I'll show you later on the difference in percentage in terms of what they are. So we're moving to 1 kilo ohm. So let's switch the scales, and it measures 985 ohms, 84 ohms on the power fix, and 983 ohms on the VENLAB. So they are quite close on the 1 kilo ohm. Now for 10 kilo ohms, VENLAB is showing 9.82, while power fix is showing 9.85, 9.84. Okay, moving up the scale, we go to 100K. You saw there's a nice beep between switching of ranges. Unfortunately, it doesn't have auto range, but so 100K reads 99.5.4 on the power fix and 99.3 on the VENLAB. So far, I really like the measurements on the VENLAB because they are identical to what I knew before as my standard. Moving up to 1 mega ohm. So it's 1.049. 1.50 on the power fix. So basically they're reading exactly the same on the higher values. And finally we have 10 mega ohms. And this one, unfortunately, the VENLAB doesn't have such a high measurement. We'll try to measure it anyway, and we'll see what happens. So on 10 mega ohms, we have 10.08. And let's see if the VENLAB will try to measure that high. No, unfortunately it reads as OL because 2 mega ohms is the highest that it can read. Oh well, that's okay. I'll try to measure my skin resistance, and I'll use the thumbs. So it reads 0.5 mega ohms. So it depends on the pressure there. That's a bit relative, so but we'll say 0.5. Oddly, it's raising up. Okay, let's see how the power fix will, and I'll do it on the same scale. Okay, 0.56, and again, same as with the VENLAB, the resistance seems to be raising, but not as much. And maybe I'm having a bit of a higher surface here because they are not isolated, but basically they are both of them reading the same. I'll have the table on screen with the differences in percentage from all of the measurements. On first glance, it looked as if they are mostly the same in terms of measurement. So I'll now continue to voltage, and I'll use DC first. Okay, so for the voltage test, I have both set on the millivolts, and I'm using my bench power supply to output 50 millivolts. I will be measuring at the poles here. So I have them unscrewed, so I'll measure on the base. You can see immediately on the VENLAB and on the power fix for that matter, there is some induced voltage from the leads that I'm holding, but at least on the VENLAB it goes to 0 when I touch both of the probes. And if I measure here, the voltage that I'm reading is 57.2 millivolts. And let's do the same with the power fix. It's 56.5. So basically 1 millivolt of difference between the two. Let's measure again. I know it's actually now it's lower, it's 56. So maybe the power supply is having some sort of a deviation. It will be difficult to measure with both at once. Yeah, pretty much straight up. Both of the multimeters are showing the same voltage. Okay, now let's increase this voltage to, this one is 200, so let's say 140. And we're measuring 147.0 on the VENLAB and 0.2 or 0.1 on the power fix, which is acceptable on both of them. Let's remove this. I'll up the scale now. I'll turn off the voltage. Okay, I've now set the voltage to 2 volts. Now the output is off, so they are both measuring 0. When I turn it on, okay, so let's reduce, both of them are, let's go down to 1.5 At 2, they are both saying that it's out of scale. Maybe the power supply is outputting something higher. So we have 1.8, 1.809 on the VENLAB and 1.811 on the PowerFix. So PowerFix is showing a bit higher voltage, but not much. So it's within specs. Now they're both equal. I think there is some variation in how I hold these probes and if I make a good contact or not. So that's fine. Let's up the scale to 20 volts and see how this same voltage will be shown. That's exactly the same on both. So far so good. Now let's set the voltage to 6.5 volts. Okay, let's measure now. The PowerFix is showing exactly 6.5, while the VENLAB is showing 6.52. And the VENLAB seems to be much more confident in the voltage. Now, since there is some voltage drop on the leads that I know of, so some resistance, the higher we go, I believe that the PowerFix will have lower readings than the VENLAB. If that is correct, if it has like a lower resistance on the leads, so that theoretically should be better. Let's see how we go. I'll up to 15.8. Not 158, but so 15.8. Okay, that's a problem because the input that I have is 13.4. So let's go all the way up. I'll add 13 volts. No, that's still too much. Let's see how much it will rise. So about 1 volt less than the input. That's fine. Let's see what it will read. 12.45, 12.49. So again, a slight offset between the PowerFix and the VENLAB, where the VENLAB is showing a bit higher voltage. Unfortunately, I don't have high enough DC voltage source to test this out on higher voltages, but let's switch to AC and I'll measure the incoming AC voltage and see what level that is. Okay, so we now have both of the meters on AC voltage. The PowerFix will go up to 250 volts, but the VENLAB will go up to 600 volts, and this is really helpful when measuring across phases. This one unfortunately cannot do that, and I have cable here coming in directly from the wall, and let's measure with the VENLAB first. Okay, that's a weird reading. Yeah, but only because I didn't have a good enough contact. So 233 volts. And you can see that the covering that comes with these leads is helpful when poking for voltages like this. Let's check the PowerFix. I need to be a bit more careful with it. And it reads 233, jumping around to 236. So you can see that probably the power fix is immediately displaying the measured voltage, while the VENLAB averages out any ripple. Unfortunately, I don't have an oscilloscope so we can see this. So you can see that it makes an average and there are no jumps in the voltage. It shows immediately 232 volts. Okay, so for this last test, I have my bench power supply set at constant current of around 20 milliamps, and I have both of the meter connected to the 200 milliamp range, and we'll measure the current that comes directly from the power supply. So first one will be the power fix, and it's saying around 19.3 milliamps. Let's see the same measurement on the VENLAB. Okay, so the VENLAB shows a little bit less, about 18.8 milliamps. Let's try to increase the range, so it's basically the same. This one shows slightly up current. Unfortunately, I don't have a third one to compare it. The bench power supply says it fluctuates around 19 to 20 milliamps, and so you can see now it's 19.4, so I can say that they are both having the same values. And with that, we can see that the VENLAB pretty much agrees with the power fix, except with some small minor differences, which in everyday working should not be too much of a hassle. I do like that the VENLAB has a light on the screen while the current multimeter does not. They both have the hold option, and the VENLAB also has the transistor measuring while it doesn't have the battery measurement. So more or less they're basically same meters, and it will definitely be used in the workshop. I'll have links to the meter down in the video description if you want to check them out and maybe buy one for yourself. And if you like this video, then I'm sure that you're gonna also love this one, so be sure to check it out and subscribe to the channel for more tests and reviews as well as electronics project.